First year chemistry exam purpose. First and foremost, you check this important question beta, Bode's theory and quantum numbers. But first, for this exam purpose, you learn this Bode's theory. Already I gave notes. Okay. So in this Bode's theory, many times I explained from where to where beta, here to, and these angular momentum equation mvr equals to nh by 2 pi. After that, these table, draw the table. According to the table, you have to draw the diagram. Okay, so up to here 8 marks you can score. Next question. Next like is hybridization beta, sp hybridization purpose. So you have to take this BeCl2 structure. Okay, after that sp2 hybridization. Okay, this is sp hybridization diagram also you have to draw. Okay, so once you check this diagram, okay, s orbital, 2p orbital, and we'll give the sp hybridization. Okay, 2 are involved in the reaction, that is why 2 orbitals are formed. Next, sp2 hybridization. Okay, sp2 hybridization purpose we will take this example BCl3 as a example. For this is the structure. Okay, what is the structure beta? Trigonal planar structure you will get like this. Already it is too late, that is why I am telling direct questions. If time is there now, next time I can explain. So please excuse me. So this is a sp3 hybridization. This sp3 hybridization purpose you have to draw the structure. Okay, so this structure is very important. Methane, especially methane molecule we have to take. Okay, tetrahedral structure. Next, after that, important SAQ. Okay, explain the dipole moment and its characteristic properties, or else explain dipole moment in H2O and CO2. H2O purpose dipole moment is greater than 0. Why? Because dipole bonds are in same direction, means some of the positive orientation there. Next, but CO2 purpose, it is in linear pattern. Okay, so the carbon is in middle. Okay, one of the direction is completely opposite to the other one. Imagine one may be plus mu, other may be minus mu. Plus mu minus mu gets cancelled, that is why 0. For CO2 dipole moment 0, for H2O dipole moment greater than 0. You must remember, you have to write like this. Okay, you may get 4 marks. Important 4 marks question, what is hydrogen bond? So the bond in between oxygen and hydrogen, or else any higher electronegative atom and hydrogen, like fluorine and hydrogen. These will make the hydrogen bond. Here hydrogen atom is compulsory, other may be higher electronegative atom. Okay, this kind of bond is known as hydrogen bond. These are two types, intermolecular bond, intramolecular bond. Intermolecular, in between two molecules the bond is formed. Here these water molecules contain one of the atom oxygen, other atom is the hydrogen. Okay, these between the molecules, two different molecules are present. In between the two different molecules, these are have bond attraction. Which bond attraction? Intermolecular hydrogen bond attraction. Next is intra. Intra means same within the molecule. Example is orthonitrophenol. Okay, orthonitrophenol. In this nitro group containing oxygen, alcohol group containing hydrogen, both will have a molecular hydrogen bond. Which one? Intra within the same molecule, hydrogen bond present. Remember, intra within the same molecule, inter in between the molecule. Okay, the hydrogen bond purpose, one is the hydrogen compulsory, other may be fluorine or oxygen, or maybe what is that beta? Nitrogen. Okay, so in between them bond is present. That's it. It is also important. 4 marks or 2 marks. Okay, please beta, please like, share, subscribe my channel Maheshwari Chemistry Classes. Please give me your support. Already it is 12. Please listen carefully. Next important question, this Kalgan or ion exchange method. For correction purpose I took this paper. Next, ion exchange method also very important question. Once you check it, here the zeolite is a nitrogen based zeolite. Nitrogen molecule is represented. Okay, So remember, these are the water treatment techniques, right? So it is also 4 marks purpose important question once you check it properly. Kalgan ion exchange method, next ion exchange method. Kalgan method this one, ion exchange method this one. Please better next time compulsory I can explain, already it is late once you check fatafat. Next, balancing the redox reactions, especially for chromate or manganese purpose, compulsory permanganate molecule or chromate molecule enable will come for external exam. Here I gave chromium, so in acidic medium. So this sort out this please. So here chromium plus 6 is converting like plus 3, nothing but electrons addition is there, that is the reduction. Here SO4 SO2 actually plus 4 oxidation state, here plus 6 there, means electrons lost there, that is why this oxidation. How it came? Through the oxygen variation, through the hydrogen variation, through the charge variation. We have to explain this balancing oxygen atom, hydrogen atom, charge, final reaction we have to write. Okay, this is also important 4 marks question. Next, one more important question. Already this over, right? This balancing reaction is important. After that, Fazan's rule, this trick box, 30 seconds trick box enough beta. What it explains beta, ionic bond nature or covalent bond nature it explains. In this once you check nana, we have to take 4 criteria. One is cationic system, one is anionic system, another with the charge variation, another with the valence shell electrons. If the big cation there na, that prefers the ionic bond nature. If the small cation there na, that prefers the covalent bond nature. Okay, so here lithium, sodium, potassium, rubidium, cesium. Cesium is a big cation, that is why it prefers the cesium prefers the ionic bond nature. Here covalent bond purpose, beryllium chloride, magnesium chloride is there. Beryllium chloride is small, that is why beryllium chloride is preferred for the covalent bond. After that, anion criteria we have to take. Okay, small anion prefers the ionic bond, so that is why fluoride is greater than iodide for ionic bond nature. Covalent bond purpose, MgI2 is greater than MgF2. Why? Because big anion, big negative charge, big anion favors the covalent character. Okay, extra electron, remember like that. Next, charge purpose, less charge prefers the ionic bond. Example, sodium chloride is greater than magnesium chloride is greater than aluminum chloride. So less charge here, Na plus 1 Mg2 plus Al3 plus less charge one preferring the ionic. Okay, means NaCl ionic nature more, AlCl3 ionic nature less, means less charge will priority for the ionic bond. But covalent purpose, more charge favors the covalent bond. These are the examples. After that, valence shell electrons. If the valence shell electrons are 8, that is ionic nature, preferring bond. Okay, best example sodium chloride, especially Na plus. Okay, sodium atomic number actually 11, 1s2, 2s2, 2p6, 3s1 we have to write. It lost third shell, valence shell electron loss, means here how many electrons beta? 2s2, 2p6 condition is there. How many electrons? Totally 8 electrons, means it prefers the ionic bond. Sodium always ionic bond, right? Next one is the 18 electrons phenomenon, that especially for the copper. Copper actually valence shell is the, what is that beta? 4s1 3d10 there. Before one we have to take, that is why 3p6 also I had taken. Okay, so if you check properly, it will give the 3s2, 3p6, 4s0, 3d10. For what purpose beta? Copper plus 1 purpose. Here 4s1 is converting like 4s0. Then third shell is the valence shell. It contains 3s2, 3p6, 3d10, means 2 plus 6 plus 10, total 18. Means 18 electrons preferring for what beta? Covalent bond. Covalent bond in a copper place. Okay, so this is the 4 criteria we have to take. Once again listen, cation, anion, charge, valency electrons. If big cation, ionic bond prefers, small cation, covalent bond prefers, small anion, ionic bond prefers, big cation, big anion, covalent bond prefers, less charge, ionic bond prefer, more charge, covalent bond prefer. Here some of the books more charge also there. Just you have to leave it. According to this only you have to learn. Next, valence shell electrons. 8 valence shell electrons prefer the ionic bond. 18 valence shell electrons prefer the covalent bond. This is a very important trick, not only for IP but also mains NEET purpose also. Next question. Next important question is Hess law beta. In all steps, how was the energy utilized? Direct in single step, that is equal. Simple beta. Several steps are equals to the single step. Okay, means direct A is converting like B, B after that C, C is after the D. A conversion into B, here it will take for example 2 kilocalories energy. B is converted into C, it may taken as 2 kilocalories energy. C is converting as D, it will take 2 kilocalories energy. Like this 2, 2, 2. Total 2 plus 2 plus 2, how much beta? 6. But direct A is converting like D, that time also it is converting like 6. Means these all conditions energy utilization are single direct product giving step also equal energy. Okay, this is known as Hess law. Simple. It states that the total energy changes, reaction is same whether the reaction takes place single step or several step. Okay, okay, reaction and sorry, if one reaction may completed in one step or several steps, that utilizing energy is equal. Okay, that delta H equals to delta H1 plus delta H2 plus delta H3. This is Hess law. Next one more important, sorry, put all the time over. Next important question is the enthalpy. This enthalpy variation, especially we have to prove the delta H equals to delta U plus delta NGRT. This is the derivation also you must remember beta. For this 4 marks purpose important. Up to here you have to write up. Once you check it properly. Okay. If you want, take a screenshot. Okay. Yes, over. Next. This one. Okay. One more important permanganate given direct MnO4 2 minus, we have to find the manganese oxidation state. Mn once you check, but sorry beta, already it is too late. Please excuse me. Now you learn these questions properly, compulsory, you will get good marks. Remaining questions also I explained in the classroom, that one also you must read. Okay, here manganese gets how much the charge beta? Plus 6 condition. Okay, and permanganate MnO4 2 minus. Do you have any doubt? Once you check in the place of Mn, same as this X we have to find, that is why X letter 4 minus 2 charge for oxygen, but whole here minus 2 there, that is why equals to minus 2 we wrote. Okay, X minus 8 equals to minus 2, X equals to minus 2, this minus will come this side plus. Okay, plus 8 minus 2 plus 8 equals to plus 6, X equals to plus 6. Okay, in permanganate manganese oxidation state is plus 6. Like this we have to find any kind of atom purpose oxidation charge. Okay, these are the some of the questions. Try to learn properly. Okay, already here I told 2 LAQs. What are those? One is Bohr's theory. Okay, already I explained this. Video is available in YouTube. Once you check in Maheshwari chemistry classes. After that, second LAQ, sp3, sp2, sp hybridization types. After that, SAQ, 3 SAQ, hydrogen bond types names. After that, SAQ is Kalgan method, ion exchange method. After that, SAQ is the Fazan's rule. After that, you have to prove the delta H equals to delta U plus delta NGRT. After that, Hess law. After that, SF6 molecule and this one beta, PCl5 structure find. Okay, phosphorus in middle and chlorine there, chlorine here. This is the trigonal pattern, below and above one chlorine there. This is the trigonal bipyramidal structure, 5 sigma bonds there, that is why it is showing the sp3d hybridization. Bond pairs are 5, lone pairs are 0. Shape of the molecule is a trigonal bipyramidal. Once you learn that structure beta, So these are some of the very important questions. Approximately here I explained in this video, I mean in this 15 minutes video, approximately 50 marks are covered. Remaining BSAQs you learn yourself. So that is your duty. Main focus, mainly you have to focus on these questions. Sorry if any mistakes are there, I mean in pronunciation. Why? Because already it is too late. I don't have any time to edit this video. Directly I am uploading. So anyway beta, thank you for your patience. Please prepare very well, and please subscribe my channel and like this video. Thank you very much.